Namaskar, I am Anand and you are watching Join for Education. Today I am going to solve the questions of exercise 15.1. Name of the chapter is Probability of class 10. Let's start the solution. Question number 1. Complete the following statements. Probability of an event plus probability of the event not E equal to 1. So the here answer will be 1. The probability of an event that cannot happen is 0. Such event is called impossible event. Here will be impossible. The probability of an event that is certain to happen is 1. Such event is called sure or certain event. So here will be sure or certain. The sum of probabilities of all the elementary events of an experiment is 1. The probability of an event is greater than or equal to 0 and less than or equal to 1. So here is the answer chart. The answer of the first question will be 1. Answer of the second question will be 0 or impossible event. Already I have said here. And answer of the question number 3, 1 to 3 is 1 and sure or certain event. Answer of the question number 4 of 1 is 1 and answer number 5 of the question number 1 is 0 and 1 already I have written here. So let's see the question number 2. Which of the following experiment have equally likely outcomes? Explain. A car driver attempt to start a car. The car start or does not start. A player attempts to shoot a basketball. C. He shoots or misses the shot. A trial is made to answer a true-false question. The answer is right or wrong. A baby born, it is a boy or girl. Let's see the answer. Here is the answer. It is not an equally likely event as it depends on the various factors such as whether the car will start or not, and factors for both the conditions are not the same. It is not an equally likely event as it depends on the player's ability and there is no information given about that. It is an equally likely event and answer of the fourth question will be also it is an equally likely event. So hope that there is no problem to understand the solution or written solution or written answer of the question number 2. Let's see the question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball at the beginning of the football game? Answer of the question 3 will be in this way. When we toss a coin, the possible outcomes are only two, head or tail, which are equally likely outcomes. Therefore, the result of an individual toss is completely unpredictable. So, see the question number 4. Which of the following cannot be the probability of an event? So, the probability of an event never be negative. So, the probability of an event E always greater than or equal to 0. Also, it is always less than or equal to 1. This implies that the probability of an event cannot be negative or greater than 1. Therefore, out of these alternatives, minus 1.5 already I have said here, be a cannot be a probability of an event. Hence, the correct option of this question will be B. Let's see the question number 5. Probability of an event P equal to 0.05. What is the probability of not E? We know that probability of E plus probability of not E equal to 1. So I have written here probability of not E equal to 1 minus probability of B. Now putting the value of probability of E here. So 1 minus 0.05 equal to 0.95. Therefore, the probability of not E is 0.95. Hope that there is no problem to understand the solution of question number 5. Let's see question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out? An orange flavored candy, a lemon flavored candy. Let's see answer of the question. The bag contains lemon flavored candies only. It does not contain any orange flavored candy. This implies that every time she will take out only lemon flavored candy. Therefore, event that Malini will take out an orange flavored candy is an impossible event. So for the impossible event, the probability of the impossible event will be 0. In question number 1, we have discussed about it. So hence, probability of an orange flavored candy equal to 0. As the bag has lemon flavored candies, Malini will take out only lemon flavored candies. Therefore, event that Malini will take out a lemon flavored candy is sure event. So probability of a sure event is 1, or here probability of a lemon flavored candy will be 1. Hope that there is no problem to understand the solution of the question number 6. Let's see question number 7. It is given that a group of 3 students, the probability of 2 students not having same birthday is 0.992. What is the probability that the 2 students have the same birthday? It means that probability of the event plus probability of not the event equal to 1. So the probability that 2 students are not having same birthday is 0.992. So the probability that 2 students are having same birthday equal to 1 minus probability of not the event. So we put here 1 minus 0.992. After the subtraction we get this one. So the answer of solution of question number 7 will be this one. Hope that there is no problem to understand. If you have problem, then join to me in my live class in YouTube every Sunday. Question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn question number first red and question number second not red? It means that event and not event. So the answer of the question number 8 or solution of the question number 8 will be the total number of balls in the bag is 3 red plus 5 black equal to 8. So the probability of getting a red ball is number of favorable outcomes will be 3 and number of total possible outcomes will be 8. So number of favorable outcome 3 and number of total possible outcomes 8. So probability of getting a red ball is 3 by 8. Of that there is no problem to understand. Probability of not getting red ball equal to 1 minus probability of getting a red ball. So we put the value of this one here. 1 minus 3 by 8 equal to 5 by 8. Of that there is no problem to understand the solution of 1 and 2 of question number 8. Let's see question number 9. A box contains 5 red marbles and 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white and not green? Let's see total number of marbles or total number of outcomes will be 5 plus 8 plus 4 equal to 13 plus 4 equal to 17. And number of red marbles equal to 5. So the probability of getting red marble equal to number of favorable outcomes will be number of red marbles. By number of total possible outcomes, it means that number of total marbles. So here will be number of red marble is 5 and number of total marble is 70. So this one will be the answer. Number of white marble is 8. So probability of getting white marble equal to number of favorable outcomes equal to number of white marbles. And number of total possible outcomes, it means that number of total marble. So we put here 8 by 70. So the probability of getting white marble is 8 by 70. Number of green marble is 4. So here will be probability of getting a green marble equal to number of green marble by number of total marble. So probability of not getting a green marble equal to 1 minus this one, 4 by 17 equal to 13 by 17. Hope that there is no problem to understand the solution of the question number 9. Let's see question number 10. A piggy bank contains 100 50 paise coin, 50 rupees 1 coins and 20 rupees 2 coins and 10 5 rupees coins. If the equally likely that one of the coin will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin, will not be a rupees 5 coin? So the piggy bank contains 100 50 paise coin. The number of 50 paise coin is 100. Number of 1 rupees coin is 50 and the number of 2 rupees coin is 20 and the number of 5 rupees coin is 10. Of that there is no problem to understand the question. So the total number of coin in a piggy bank equal to possible outcomes. So the total number of possible outcomes will be 100 plus 50 plus 20 plus 10. Here 100 clear that number of 50 paise coin. Here 50 clear that number of 1 rupees coin. Here 20 clear that number of 2 rupees coin and here 10 clear that number of 5 rupees coin. After the addition we get 180. So see here number of 50 paise coin is 100 according to the question. So the probability of getting a 50 paise coin will be number of favorable outcomes equal to number of 50 paise coins and by number of total possible outcomes is 180. After the cancelled out of the common factor we get here 5 by 9. So the probability of getting a 50 paise coin will be 5 by 9. So this is the answer of the question number 1 of main question 10. So let's see. Number of 5 rupees coin is 10 according to the question and probability of getting rupees 5 coin equal to number of rupees 5 coins by total number of coins equal to, after the cancelled out of the common factor we get here 1 by 18. So this is the probability of getting a 5 rupees coin. So the probability of getting not a 5 rupees coin will be 1 minus 1 by 18. After the calculation we get here 17 by 18. So hope that there is no problem to understand the solution of 1 and 2 of the question number 10. If you have problem, join to me in my live class in YouTube every Sunday. I shall solve each question with the help of the blackboard. So join to me. Question number 11. Let's see. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out 1 fish at random from the tank containing 5 male fish and 8 female fish. See the given figure. This is the given figure. What is the probability that the fish taken out is a male fish? So the number of favorable outcomes here will be 5 and number of the total possible outcomes will be 5 plus 8 will be 13. So the probability of getting a male fish is 5 by 13. Let's see here total number of fishes in the tank according to the question is 13, and probability of getting a male fish equal to number of favorable outcomes equal to number of male fish by total number of possible outcomes. So here will be 5 by 13. Of that there is no problem to understand the solution of question number 11. Let's see question number 12. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1 to 8. See the given figure, and these are equally likely outcomes. What is the probability that it will be point at 8, an odd number, a number greater than 2, a number less than 2. So the higher total number of possible outcomes will be 8. To get 8, here favorable number of favorable outcomes will be 1 for question number 1. An odd number, then we see here what are the odd number 1, 3, 5, 7. So the number of odd number is 4. So the here number of favorable outcomes will be 4. A number greater than 2, it means that 3, 4, 5, 6, 7, 8. So the number which are greater than 2 are 1, 2, 3, 4, 5, 6. So the number of favorable outcomes of question number 3 of 12 will be 1, 2, 3, 4, 5, 6. A number less than 9, it means that all numbers are less than 9. So the here number of favorable outcomes will be 8. So we have total number of possible outcomes and total number of favorable outcomes. Then we have no problem to find out the probability. We know that probability equal to total number of favorable outcomes by total number of possible outcomes. For the question number 1, this one will be 1 by 8. For the question number 2, it will be 1, 2, 3 and 4. 4 by 8 equal to 1 by 2. A number greater than 2 for this probability of this event will be 1, 2, 3, 4, 5, 6. 6 by 8 equal to 3 by 4. A number less than 9 for this event here will be 8 by 8 equal to 1. So let's see probability of getting 8 equal to 1 by 8. Of that there is no problem. Already I have discussed about it. Total number of odd number on the spinner is 4. Already I have discussed here. So answer will be 1 by 2. Already I have discussed the number greater than 2 are 6. So here will be 6 by 8 and the answer will be 3 by 4. Already I have discussed now the number less than 9 are 8. So the probability of getting a number less than 9 is 8 by 8 equal to 1. So hope that there is no problem to understand the solution of question number 1 to 4 of question number 12. If you have problem, join to me my live class in YouTube. Let's see question number 13. A die is thrown once. Find the probability of getting a prime number. A number lying between 2 and 6, an odd number. So here total number of possible outcomes will be 6 in case of dice. Prime number, it means that 2, 3, 5. The number of prime numbers are 3. Here favorable number of favorable outcomes will be 3. 3 by 6 equal to 1 by 2. Number lying between 2 and 6, 1, 2, 3. Here favorable number of favorable outcomes will be 3. 3 by 6 equal to 1 by 2. An odd number, it means that 1, 3, 5. So the number of odd number equal to number of favorable outcomes will be here also 3. So the probability of this one will be 3 by 6 equal to 1 by 2. Let's see the Solution of this question: the possible outcomes when a dice is thrown is 1 to 6. Of that there is no problem. Number of possible outcomes of a dice is 6. Prime number on a dice are 2, 3, 5. So the number of favorable outcomes here will be 3, and the probability of getting a prime number equal to 3 by 6 equal to 1 by 2. Already I have discussed about this one. And number lying between 2 and 6, 3, 4, 5, already I have discussed. Total number of lying between 2 and 6 are 3. So the probability of this one will be 1 by 2. And odd number on a dice is 1, 3, 5. So the total odd numbers on a dice is 3. And probability of getting an odd number is 3 by 6 equal to 1 by 2. So the probability of this one will be 1 by 2. Let's see question number 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of a red color, a face card, a red face card, a jack of hearts, a spade, the queen of diamonds. So the answer or solution of the question number 14 will be total number of cards in a well-shuffled deck is 52. So the total number of possible outcomes is 52. For the question number 1, number of favorable outcomes is 2. So the probability getting a king of red color will be 2 by 52. After the cancelled out of the common factor, we get here 1 by 26. Total number of face cards is 12. So the getting a face card or probability of getting a face card equal to number of favorable outcomes will be 12, and total number of possible outcomes is 52. After the cancelled out of the common factor, we get here 3 by 13. So the answer of this one will be 3 by 13. Total number of red face card is 6. So the here probability of getting a red face card equal to number of favorable outcomes by number of total possible outcomes equal to 6 by 52. After the cancelled out of the common factor, we get here 3 by 26. Total number of jack of heart is 1. So the number of favorable outcomes is 1, and number of total possible outcomes is 52. So the answer of this one is 1 by 52. Total number of spade card is 13. So the total number of favorable outcomes is 13. Probability of getting a spade card equal to number of favorable outcomes here will be 13. Number of total possible outcomes will be 52. So this one will be 1 by 4 after the cancelled out of the common factor. Total number of queen of diamond is 1, and so the probability of getting a queen of diamond equal to number of favorable outcomes. Here number of favorable outcomes will be 1, and number of total possible outcomes is 52. So these are the solution of the question number 14. Hope that there is no problem. If you have problem, please join to me in my live class in YouTube. I shall clear all of the doubt. Let's see question number 15. 5 cards, the 10, jack, queen, king and ace of diamonds are well shuffled with their face downwards. One card is then picked up at random. What is the probability that the card is the queen? If the queen is drawn and put aside, what is the probability that the second card picked up is an ace, be a queen? Let's see here for the first part of the question number 1, total number of favorable outcomes or total number of cards is 5 and total number of queen is 1. So the possible outcomes is 5, favorable outcomes is 1. So the probability of getting a queen will be 1 by 5 according to the general formula. probability of element equal to number of favorable outcomes by number of total possible outcomes. When the queen is drawn and put aside, the total number of remaining cards will be 4. So here will be possible outcomes, total number of possible outcomes will be 4 and the favorable outcomes will be 1. So the probability of getting an ace will be 1 by 4. So as queen is already drawn, therefore the number of queen will be 0. So the getting or probability of getting a queen is 0 by 4 equal to 0. Of that there is no problem to understand the solution of question number 15. Let's see question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen is taken out is a good one. So here total number of possible outcomes will be 144 defective plus non-defective. Total number of good pens is 132. So probability of getting a good pen equal to number of good pens by total number of pens equal to 132 by 144. After the cancelled out of the common factor, it will be 11 by 12. Let's see question number 17. A lot of 20 bulbs contain 4 defective ones. One bulb is drawn at the random from the lot. What is the probability that this bulb is defective? Suppose the bulb drawn in first is not defective and is not replaced. No one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? From the question it is clear that total number of bulbs is 20. Total number of defective bulb is 4. So probability of getting a defective bulb equal to number of favorable outcomes here will be 4 and number of total possible outcomes here will be 20. So it will be 4 by 20. After the cancelled out of the common factor we get here 1 by 5. So this is the answer of the first part of the question number 17. Let's see second part of the question number 17. Remaining total number of bulbs is 19. So the remaining total number of non-defective bulbs 16 minus 1 equal to 15 and getting a not defective bulbs is 15 by 19. Hope that there is no problem to understand the solution of the second part of the question number 17. Let's see question number 18 of this exercise. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square number, a number divisible by 5. So total number of discs is 90. Total number of 2-digit number between 1 and 90 is 81. Getting a 2-digit number or probability of getting a 2-digit number will be total number of favorable outcomes is 81 and total number of possible outcomes is 90. After the cancelled out of the common factor we get here 9 by 10. Perfect squares between 1 and 90 are 1, 4 and the number of this one is 9. So probability of getting a perfect square will be number of favorable outcomes which is 9 and number of total possible outcomes which is 90 After the cancelled out of the common factor, we get here 1 by 10. So the answer of the second part of question number 18 is 1 by 10. Number that are between 1 and 90 and divisible by 5 are 5, 10, 15. So the number is 18. So the probability of getting a number divisible by 5 is 18 by 90. After the cancelled out of the common factor, we get here 1 by 5. Of that, there is no problem to understand the solution of 1, 2, 3 of question number 18. If you have problem, then join to me in my live class in YouTube or join my WhatsApp group. There I shall available PDF solution of this exercise. Let's see question number 19 of the exercise. A child has a die which 6 passes solve the letter as given below. A, B, C, D, E, A. The die thrown once, what is the probability of getting A and what is the probability of getting D? So here the number of A is 2, therefore favorable outcomes, number of favorable outcomes will be 2 and possible outcomes will be 6. So here will be 2 by 6. After the cancelled out of the common factor, we get here 1 by 3. So the answer of the first part of the question number 19 is 1 by 3. Total number of faces having D is 1. So the number of favorable outcomes is 1. So the probability of getting D will be 1 by 6. Of that, there is no problem to understand the solution of first and second part of question number 19. Let's see question number 20. Suppose you drop a die at random on the rectangular region shown in the given figure. What is the probability that it will be land inside the circle with diameter 1 meter? So see here, area of the rectangle will be length into width equal to 3 into 2 equal to 6 meter square. Area of circle of diameter 1 meter equal to, we know that the formula of the area of a circle is pi r square. Now we putting the value of r. R is the half of the diameter and here diameter is 1, therefore radius will be 1 by 2. After the calculation, we get here pi by 4. So die will land inside the circle. So the favorable outcomes will be pi by 4 and total number of possible outcomes will be 6. So we put here pi by 4 by 6. After the proper calculation, we get here pi by 24. So this is the solution of question number 20. Hope that there is no problem to understand this solution. Let us see question number 21 of this exercise. A lot consists of 144 ball pens, of which 20 are defective and other are good. Nuri will buy a pen if it is good, but will not buy if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy and she will not buy? Total number of pen is 144 according to the question. So this one will be the total number of possible outcomes. Total number of defective pen is 20 and therefore total number of good pens will be 124 and 144 minus 20 equal to 124. Probability of getting a good pen equal to total number of good pen by total number of pen. So 124 by 144. Of that, there is no problem to understand at this step. After the cancelled out of the common factor, we get here 31 by 36. So this is the answer of the first part of question number 21. Let's see second part of the question. Nuri will not buy a pen equal to, in that case Nuri will buy a pen. So this one will be 1 minus 31 by 36 after the proper calculation we get here 5 by 36. So this is the answer of the second part of the question number 21. Probability of Nuri will not buy a pen is 5 by 36. Of that there is no problem to understand the solution of this question. Let's see question number 22. Two dice, one blue and one grey, are thrown at the same time. Write down all the possible outcomes and complete the following. Event: sum of two dice 2, 1 by 36, 3 and so on 12, 1 by 36, 8, 5 by 36. So see here, if we put here then 3 by 36 and so on, and we complete this, fill in the blanks. So I leave answer of this question for all of you. Let's see question number second part of this question. A student argued that there are 11 possible outcomes 2, 3 up to 12. Therefore, each of them has a probability 1 by 11. Do you agree with this argument? It can be observed that to get the sum of two possible outcome 1, 1, 3, or 2, 1, 1, 2 and so on. Here is the see the table, and so we fill the blanks. So the answer of this one is this one. Hope that there is no problem to understand. If you have, then join to me in my YouTube live class. Probability of each of these sum will not be 1 by 11 as these sum are not equally likely. So I shall solve rest question of this exercise in the next video lecture, and hope that all solution will be useful to the students who are studying in class 10. If you think that this solution is useful to you, then please do circulate other students of your surrounding so that my work will be effective. My next video lecture will be related to the solution of the next questions of this exercise. Till then, thanks to all of you. Thank you very much to stay with me.